This presentation is about unlabeled dataset as given, which is known as unsupervised machine learning algorithm, and K-mean is the most popular method. Clustering is a technique for determining trend and pattern in unlabeled dataset by employing a centroid and the distance between it and the other points without data training required. K-mean clustering algorithm is best illustrated in pictures. The traits or attributes are compared here, and all things with similar properties are grouped together. This flowchart shows how K-mean clustering works. Start by choosing K as number of clusters by trial and error, and then continue with alpha method. Measure the distance from each point to the assigned centroid. Continue with grouping based on the minimum distance. Reposition the original centroid to the new centroid in the center of each cluster for optimization. Repositioning and calculating distance measure keep repeated until it stops and conversion. An e-commerce store PR plan to build a hub in a city and find the best location to optimize profit. K-mean is used to determine the number of hub and optimal location. In this picture, two centroids are assigned. There are four methods in distance measure. The most popular is Euclidean distance measure with formula is shown. The elbow method is the best way to determine the optimum k-value as the number of clusters WSS is calculated from the sum of the square distance between each point of the cluster to its centroid. The lower value the better, which means the points are close together. In the first picture, the centroids are assigned and distance are measured. Secondly, the actual centroid of data points is calculated from mean points and repositioning the random centroid to the actual centroid after k equals to 2. Insignificant change of WSS so that elbow point value is the final number of cluster. K-mean is converged and C1 and C2 represent the recommended location to reach customers. One of fascinating application of K-mean clustering is color compression inside photograph. To improve memory, some gadgets may have limitations that limit the number of colors that can be produced. Color quantization is useful in improving memory by decreasing the amount of color in an image. Despite the loss of details in the last panel, the overall image is still visible. K-mean also used to detect brain cancer with real-time processing during surgical procedures. Here are some other applications of K-mean. K-mean has limitations such as difficulty to forecast number of cluster K, not suitable for complex spatial view cluster as well. K-mean is easy to implement and understand. It is also applicable to large dataset and guarantee convergence. On the other hand, the k-value should be chosen manually and dependent on the initial value of k, clustering data with varying size, density, and outlier as well. If k-mean fails, then hierarchical clustering and DBS scan clustering can become alternative. Thank you for listening and your kind attention.